Alright, so today we want to look at what consecutive and non-consecutive force. Then the definition of consecutive force, we are seeing that is a force for which the work done in a moving an object between 2 points is independent for the path taken. And that example of consecutive force is what? Gravitational force, right? And then when you look at consecutive force, it will be when the total mechanical energy of an object is what? It is conserved. Meaning that obvious, remember when we were dealing with work energy and theorem, we say that if there's no what? The presence of plate force, frictional force, the Emac at initial there, it equals to what? Emac final, right? And it means that if let's say this object comes here and goes there, then when you calculate the work done by the gravity here, we get what? Maybe negative. And then when we calculate it, our work done by gravity, whereas the object goes up, we get a positive work done by gravity. And when we add them, we must get what? 0, because like we're adding negative 10 plus 10, and then we get what? 0 work net. That is a consecutive force that is done by what? That is a force that is done by consecutive force. And consecutive force, it happens when your total mechanical energy of an object, it is what? It is conserved. Now let's look on non-consecutive force. So before we go on non-consecutive force, you must know that now if we have a presence of non-consecutive force, that means that the total mechanical of that object is not conserved, meaning that the Emac initial is not equals to the Emac final. So the definition is say that the force for which the work done in moving an object between 2 points depends on the path taken. And you know the example of non-consecutive force, which is force applied, frictional force. We also have what? Tension, and what else? A resistance. And also we have a definition of work energy theorem in terms of non-consecutive force. That means that you add the equation of what? Work energy theorem, which is work net is equals to change in kinetic energy. Then that says that the work done on an object by non-consecutive force, it will be equals to the sum of the change in kinetic energy and potential energy of that object. That means that you're going to say work done by non-consecutive forces, it will be change in kinetic energy, change in potential energy. And then work done by negative forces, it will be the total work done by non-consecutive forces. So let's say in a diagram they talk about force applied as well as the what? Force applied and Fk. That means that the work by non-consecutive forces, it will goes to what? Work done by the Fk, and also plus or minus according to the what? The sign of your force work done by what? By Fk, right? And then that is a work done by non-consecutive forces. And also how work calculation, rather you can also use what? Work net by, that is goes to what? Change in kinetic energy, or you're going to use work net by non-consecutive forces. So now let's look at this following question. It says that we have a 70 kg skateboarder which skates down a slope while experiencing a frictional force of 119 0 newtons. Oh, shame on me. All right. The slope, that's from an angle of 30. And then the skateboarder covers a distance of 10 meters from point A and point B. And they say the speed of the skateboarder at point what? A, it is 6 meters, meaning that his initial velocity is 6 meters per second squared. Now they say that you must calculate the gravitational force, the gravitational potential energy of the skateboarder at point A. So we know that the gravitational force will be what? M, gravity, and the height. And this height is what? Is your delta y. But when you look at the diagram, can I draw it here? We have an angle of theta, and we have the delta x, which is how much? 10. But you don't have delta y. To get that one, you're gonna say delta y, that is equals to sine theta multiplied by delta x. And then we're gonna say sine of what? Sine of 30 multiplied by delta x, which is 10. And then you go to how much? 3430 joules. That is a no, this, sorry, oh Jesus Christ, this will be how much? 5 meters. And then when you calculate your gravitational potential energy, you're gonna see what? 70 gravity 1,8 delta y 5. Then how much is that? There is the answer that I wrote there by mistake. Then therefore going to be 3,430 joules. Then now let's look at B. B says that you must calculate the speed of the skateboarder at point B. Remember, at point A, that is his initial speed, 6 meters per second. And then B, we don't have that final speed. So basically, we're looking for the final speed. And then now we're given the force. That means that the work done by non-consencutive forces, it will be work done by what? By Fk. And then let's quickly find work done by the Fk, which it will be 190 times the delta x that is covering, and you know that Fk is what's cos 180. Then therefore we get negative, because of course 180 is equals to negative 1. Remember that. Then therefore work done by non-consencutive force, or rather work done by the Fk, we're getting negative 1900 joules. Then from there we can simply say work done by non-consencutive force is equals to the change in kinetic energy plus the change in gravitational potential energy. Now let's break it down. This one, it will be 1/2 mass final velocity squared minus 1/2 mass initial velocity squared plus mass gravity final height minus mg initial height. Height. I nearly said to the power of 2 there. All right, and therefore we're gonna see what now. Let's see. We have the mass, right? Final velocity. So what you are looking for? We have initial velocity, yes, as much 6 meters. And then do we have final height? Our final height, it will be 0. Our final height, it will be 0, because what is the height at B? 0, because it's reached the ground. And then our initial height there is what? The one that we have calculated as what? As 5 meters, because this is our initial height there is what? As 5 meters. So let's quickly substitute our values there. So you're gonna say 1/2 the mass of 70, the final velocity, so what you are looking for, minus 1/2 by 70 initial velocity there, 6 squared. 6 squared, right? Divide the bracket and say plus, what is the final height? You say that is 0. That means this, we don't have the kinetic potential energy at point B, therefore equals to be 0. Then we say bracket minus what the mass there is 70 by 9,8, and then what is the height? Initial height was what? 5. And then when we substitute, how much are you getting? When you substitute, how much are you getting? Therefore, you will get 35 final squared. And you will minus it by what? By 1260 from here when you punch it in a calculator. And then you're going to have minus, because positive times minus, you get minus. And our potential gravitational energy at point A, it will be what? The one that we've calculated, which is what? 340. And remember, when the work done by non-consecutive force, it is negative 1900 joules. And then now, when you transpose that thing, okay, let me write here, you're going to have negative 190. You transpose what? So when you add this amount, you must get what? Negative. That means that it will be positive 4690. That equals to 35v squared divided by 35 divided by 35. Then the v squared, it will be equals to 79,71. And then when you square root both sides, that means that you're going to have what? Vf, that is close to how much? 8,93 meters per second. That means that we have the final velocity at point B as how much? 8,93 meters per second. Okay, let's look at this question. It says that we have a car with a mass of 900 kg that travels up a 20 meters long hill with a constant slope. Constant slope. You see that it maintains a constant velocity of 36 kilometers per hour. Constant velocity. That means that your F net is what? It's close to 0, or rather the velocity is what? 0. Alright, see, basically this car, let's say a test. I'm sorry, a test. That's what? Let's go up a hill, and then they say that the work done by the FK is how much? Is 50 kilojoules. That means we need to convert it to what? To joules. How are you going to convert that? You're going to multiply by 1000. And the net work done by the engine there is how much? Is 72.3 kilojoules. Then therefore we're going to multiply by 1000 so that you can have what? Joules in correct SI units. And therefore they're saying that this car is being pulled by the force of the engine, right? So we're going to force of applied, and we have what? Fk. And then they said what? Concept velocity. That means that anything concerning velocity, we don't consider it, because they give us what? Constant what? Velocity. Now, work done by what is meant by consecutive force. You know that consecutive force is a force for which the work done in moving an object between 2 points is independent from the path taken. Now, 2.2 say that we must calculate the height of the hill using the energy principle. Now, to calculate the height, that means that now we must go to energy, gravitational energy, so that you can calculate the height, because the initial height there, it will be 0. The initial height is 0, and the final height, it will be the one that you're gonna look for. And also when you talk about the initial speed there, they say that it's 36 kilometers per hour, and also they say that we're given constant velocity, and then that means that now we don't have the Emac of that object. That means that because of constant velocity, we say that the velocity there will be 0, and now when you calculate the initial, we get 0, as well as when we calculate the initial kinetic energy, we get 0, as well as when we calculate the final initial, we get 0. So basically the Emac there is how much? It will be 0, meaning that when you go from work done by non-consecutive force, we say that you're going to have change in kinetic energy plus change in gravity, then this thing, it will be 0. Right? Now let's add our work done by non-consecutive forces. Before we add them, we must convert them into into joules, meaning that when you multiply the work done by Fk, they say that is 50 kilojoules. Then you want to multiply it by 1000, then you get 50,000 joules. And then work done by force applied, which is the work done by the engine, it is 52,3. Then you want to multiply by 1000, then you get how much? 72,300 joules. And when you add work done by gravitational force, when you add them both that side, you get 122,300 joules. Now we have work done by non-consecutive force. Now let's look here by the change in gravitational potential energy. Now you're gonna see, okay, let's break this apart. We know that we have mass, height, final height minus m, and initial height. But remember, initial height is is 0. That means that you don't have initial gravitational energy. So basically we have work net that is equals to final gravitational energy. So we're gonna say 122,300, which is work done by non-consecutive forces. Then the mass of that car is 900. Then gravity is 9,8, and the final height is what we are looking for. And then when you divide by rather, what is the total of when you punch it in calculator? 900 times 9,8, you get 8,822. Remember, we still have final height. Then now we can easily divide it by both sides by by 8820 by 8820, and the final height of that, it will be 13,87 meters. Then now let's look at 2.3. They say that calculate the force exerted by engine. How you go calculate the force that is exerted by engine? Remember, they give us done by they give us work done by the force applied, which is work done by the engine. So therefore you can simply say that work done, remember, it is equals to that, and we have the delta x, and we know the angle of force that is between force applied by engine and also the delta x, it will be 0 because of what? We cover the delta x in that direction and you get what? 0. So work done by the force applied by engine, it is equals to what? Or rather, they say that is equals to what? 72.3 kilojoules. But when you convert it in joules, rather we have converted in joules. So therefore, it's 72,300 watt joules. Then therefore, we know that you're going to have what? Force applied delta x and a cos of what? And a cos of theta. And then you're going to say 72,300 joules. That is close to force applied. So what we're looking for, we know that delta x is what? 20 meters and a cos of what? Cos of 0. And then 20 times cos 0, we know that is 20. Then therefore we're going to divide both sides by 20. Then the force applied there by engine, it will be how much? So basically we're going to say 72,300 divided by 20. It will be what? Close to 3,615 newtons up the what? The incline.